Capacitor starts to increase so that a constant current I starts to flow through the circuit. So how the circuit will be? So this is the resistance. Capacitance should increase, no? So for the capacitance to increase, what is the area of cross section? I cannot do anything. So it's a, and there's no dielectric slab. The distance between the plates should decrease, no? So there's the initial C naught R, and it is connected to a constant voltage source V. This is T equal to 0. Let's assume that one. Now at any time T, where X will be less than D naught. I think there's the only possible way in which I can vary the capacitance. So that a constant current I flows. Is it possible for the current to be constant? Yeah, it should be like this. Polarity plus minus, charge will be Q plus Q minus Q. Let's write. Doesn't need it. I just wanted to analyze this particular circuit, you know. So what is the equation now? This will be V minus IR Q by C. And trying to guess a situation. Okay, just assume that capacitance will increase, no? So for capacitance to increase, the separation with the plate should be decreased here. So there is, and its capacitance starts to increase so that a current I starts to flow through the circuit. Not, there's no external agent. There's no external agent. So the other capacitance, so definitely the force of attraction between the plates. And what is Fe? Fe should be equal to Q square by 2A epsilon naught. And because of force acting, they will have velocity. I think some all this such things are happening in this particular situation. Okay, let's not get into writing equation and do something here. Himself he said current constant. What is the power supplied by the source? V into I. It's quite natural. Thermal power generated in the resistor connecting wires. Connecting wires will have a resistance. That's mean here. Resistance of connecting wires. That connecting wires only I'll showing resistance. So I square R. Okay, there's no problem with this. Rate of increase of electrostatic energy stored in the capacitor. There's a power supplied by this. Okay, fine. There's some power dissipated in this. The difference of these two. So what happened will be half of it will go in the capacitor. So remaining something, no? See, Vi minus I square R. Vi minus I square R is given to the capacitor. In that what happened again, the energy available across capacitor, half of it will be available for increase in elastic potential or electrostatic potential. Remaining this part of energy, where do it has gone? Because the plates what happen, they must possess kinetic energy, no? because the electrostatic force does positive work here. Kinetic energy of the plates will increase. Then if a force does positive work, and moreover it's electrostatic force, so conservative force does positive work, potential energy should decrease here. So therefore, the decrease in potential energy, where it will go? Get converted into increase in kinetic energy. So how to show this? I think this is quite natural, no? Vi minus I square R will be available across capacitor. I'll take it on this. They may not help us anything mathematics here. No. So first, work done by the cell, power supplied by the cell, Vi, power dissipated across resistor, I square R. The power available across the capacitor. I'll say the power available across cell. I think there's a natural rule, no? I think I'll begin like this. The power generated by cell is given by this one. Some power will go to the connecting wires, and remaining power will be given to capacitor. What is this PC I should call? Power available across capacitor. Okay, this will be Vi equal to I square R PC. Now after this available, there'll be, and current is a constant current. Current will be constant. So what happens to this power? A part of it will be utilized to increase potential energy, and the remaining output will be converted into kinetic energy. So what is this PC? PC should be equal to, again, part of it. I'll take help of this sentence. Power available across capacitor equal to rate of increase in potential energy of capacitor, electrostatic, electrostatic potential energy of capacitor plus rate of increase in kinetic energy. Now, few things like why kinetic energy it has to be brought, because the force is acting. How capacitance can vary? See, capacitance can vary only when the distance should vary. How the distance will vary? The plates open should be set free to move. The electrostatic force does work. Because of that, kinetic energy of the plates will increase. Okay, like this I am putting here now. Okay, now what about their ratio? In what proportion these two will be? Where do we have come across this such a thing? I think you go back to the dielectric slab between the plates, no? Each generator will be zero. What all that particular thing is there, no? Half of it will be converted into kinetic energy of slab. Remaining will be there in increase in potential energy of the capacitor. You have to go back to the things what you learned. These two will be in equal proportion. So therefore, okay, this I think du by, I'll write it. This will be dkt by dt.